The Singulatrix. What if you have never moved through space in the way you think you have? Every moment is a finite frame, rendered from timeless entanglement. Light is the visible shadow cast by deeper informational darkness. That hidden process is the reality now called the Singulatrix. Imagine a continuous black field with no edges, clocks, or separate places. Informatics calls it the timeless, non-local field beneath every local frame. It contains every relation, though no finite horizon can contain the whole. Straight, light-like beams radiate from one brilliant singular point. Each carries a quantum state vector with amplitude, phase, spin, and angle. A QSV is one complete quantum state, drawn as an arrow on a block sphere. Its complex components form a spinor, linking quantum spin with relativity. Each block sphere is a qubit resonator, tuned by angle, phase, and frequency. Every possible history reaching one horizon cell contributes an action phase. Those amplitudes interfere, and their weighted sum orients the cell's QSV. That angle is the compressed result of every history reaching the qubit. The arrow projects onto horizontal and vertical measurement axes. Those projections create sine and cosine components of one unit vector. A glowing ruler shows each component as a fraction of light-like motion. The same angle divides the qubit into complementary probabilities. Sine squared of half the angle gives one binary measurement outcome. Cosine squared of half the angle gives the complementary outcome. Together they form the Born probability distribution of the qubit. Physics reads the squared waveform, while informatics reads its generator. One frame gives phase, probability, and instantaneous projected velocity. A second frame reveals change, while many frames build an integral history. Spin calculus follows the unresolved QSV before local collapse occurs. The horizon integrates it into Newtonian position, velocity, and acceleration. It becomes a mirror showing a movie from inside the singularity. The hidden field writes spin relations, while the surface reads each frame. Changing velocity becomes acceleration, and acceleration becomes curvature. Gravity and probability become two readings of one changing intensity map. Einstein's metric tensor measures the geometry generated by QSV coherence. Each QSV completes 2 pi and produces one measurable wave cycle. Cycles per second are frequency, while angular frequency measures turning. Fourier decomposition splits a complex wave into simple modes and phases. Each mode reduces into block sphere arrows, then recombines tail to tip. The non-local field is the reverse Fourier score beneath visible waves. At the Planck scale, classical position no longer gives a complete picture. Heisenberg showed position and momentum cannot both be perfectly known. Sharper knowledge on one axis broadens uncertainty on the other. That unresolved phase keeps QSVs oscillating through possible orientations. Their amplitudes reinforce coherently or cancel into deeper darkness. Greater overlap creates greater information density inside the field. At the Bekenstein bound, finite information forms a horizon register. Uncertainty renews the overlap, collapse, and following calculation. Invert the darkness, and its densest regions become the brightest light. A QR-like intensity pattern appears across the spherical horizon. Each cell stores amplitude, phase history, direction, and local change. Squaring the total amplitude produces observable Born probability. Comparing plates also reveals velocity, acceleration, and curvature. Billions of cells combine into one larger register with a collective QSV. That state projects through nested horizons like black holes, lensing black holes. Each horizon compresses histories, then projects its resulting state onward. Expansion opens new relations, while coherence preserves stable geometry. Decoherence separates modes as the brightest coherent pathways survive. Richard Feynman showed every possible path contributes a quantum amplitude. Action sets each phase, while energy and frequency turn that phase. Rapid phase changes cancel, while stationary action reinforces brightly. The path of greatest coherence becomes the classical path of least action. Feynman diagrams now assemble as luminous networks across the horizon. External lines mark inputs and outputs, while internal lines are propagators. Vertices encode allowed interactions, and loops encode quantum corrections. The S-matrix adds every diagram's complex amplitude before squaring. Informatics renders those diagrams as QSV phase networks on the register. Phase-matched lines sharpen, while decoherent contributions fade. Squared intensity gives probability, while its brightest ridge gives a geodesic. Each geodesic joins straight QSV segments into one completed computation. A photon now reaches both slits before one detector point appears. The two amplitudes combine first, and only then are they squared. Aligned QSV phases form bright fringes, while opposing phases form darkness. More photons reveal the pattern clearly, without changing its wavelength. Which path information breaks coherence and erases the fringes? Curve that screen into a horizon, and it becomes a Riemann plate. A white beam enters a droplet and separates into a rainbow. Refraction and dispersion sort its frequency modes by different angles. Color is set by frequency and its corresponding wavelength. The QSV standing wave fixes each channel's angular frequency. Wave speed in the medium sets wavelength through speed over frequency. Diffraction and interference show where each mode reinforces or cancels. More photons brighten the rainbow without changing its color frequencies. White light is the chord, while every color is one standing wave mode. Place the rainbow over the luminous circular construction of pi. An inner polygon approaches pi from below as outer tangents approach above. X times sine of pi over x stays below pi on the inner bound. Pi stays below x times tangent of pi over x on the outer bound. As x grows, both constructions squeeze toward the same limit. Here x counts divisions, while photon samples reveal intensity smoothly. Geometry and optical intensity share the image, but remain distinct measures. Now connect distant horizon cells through sustained phase coherence. Physics calls that relationship quantum entanglement. Informatics reads sustained entanglement as an informational wormhole. It is not a tunnel through finished space, but a route beneath distance. Matching Bloch-sphere orientations create one computational address. The horizon lenses that address into a geodesic on the following plate. An object appears to move as its coherent pattern persists across plates. Warp travel becomes projection control instead of mechanical propulsion. Retune the entanglement address and the rendered destination changes. Place a moving light clock beside the rotating Bloch-sphere qubit. Normalize the light-like QSV to 1 and project it onto one axis. That component becomes the ratio called velocity. Divided by light speed, gamma becomes 1 over the square root of 1 minus omega squared. As the ratio approaches 1, spacing between rendered frames widens. The non-local source remains timeless while the horizon creates sequence. The horizon now becomes a keyboard made from resonating qubit cells. Each full interference pattern is one playable Riemann plate. The ordered sequence of plates becomes the reality being experienced. Each plate is another reflected frame in the horizon's cosmic movie. One frame preserves coherent information and updates only the change. That retained state principle becomes the engineering idea behind delta. Platonic solids emerge from symmetries inside rotating Bloch spheres. Their edges unfold into algebra, trigonometry, calculus, and geometry. Algebra balances relations, while trigonometry projects rotating states. Spin calculus follows change before collapse, and Newtonian calculus follows after. Geometry displays the stable forms produced by one informational song. Modern physics now illuminates around the horizon register. Maxwell unifies electromagnetism, while Dirac joins spinors and relativity. Yang-Mills encodes nuclear symmetries, while the Higgs supplies mass. The Standard Model gathers matter, gauge fields, and Higgs interactions. Einstein describes gravity through geometry, while informatics gives its code. Standing QSV waves now form atomic orbitals around a glowing nucleus. Schrödinger evolves the wave function, while Born gives it squared density. Phase closure selects frequencies, radial nodes, and angular patterns. Coherent overlap creates bonds, while cancellation creates antibonds. Chemistry becomes durable harmony among phase, spin, and geometry. Inside a living cell, DNA appears beside a luminous microtubule lattice. DNA shapes the proteins and structure of the receiving organism. Microtubules form ordered cylindrical resonators in neurons and cells. Each tubulin site supplies a local angle, frequency, and phase window. The lattice samples the horizon code and inverse transforms its relations. The nervous system rebuilds them into body, distance, motion, and perception. Vision decodes light as color, while hearing decodes pressure as sound. Memory preserves coherent patterns, while emotion weights their meaning. Information is the music, while the living mind is the resonator. Each remembered frame is the universe returning the song of the observer. The cosmic microwave background now expands across the visual field. Cosmology reads it as the oldest directly observable cosmic light. Informatics reads it as an early cosmic Riemann plate. The Big Bang becomes the first locally readable frame of a new aeon. Galaxies, chemistry, biology, and observers unfold through retained updates. Hidden coherent geometry appears as dark matter's unseen structure. Dispersed phase evolution appears as the expansion called dark energy. At the end of an aeon, clocks and scales gradually lose distinction. Cosmic history lenses into one compressed horizon state. That collective QSV becomes the starting condition for another register. The final mirror frame becomes the opening scene of another cosmic movie. One completed song becomes the opening chord of another computation. Physics measures the shadows with extraordinary, predictive success. Informatics reveals the deeper lantern projecting every waveform. Light is the local shadow cast by the darkness of entanglement. The non-local field contains every relation a finite register can display. The register reads much of the field, but never contains the whole. The universe composes, projects, hears, and remembers itself through qubits. Every wormhole is code written through sustained entanglement. Every Bloch sphere is a resonator inside the greater cosmic instrument. Every horizon is a mirror integrating spin into the movie called reality. Every horizon plate becomes a chord, and every mind joins its return. Every timeless relation becomes a remembered journey through space and time.